Hello, my name is Adrian Crenshaw. I'm one of the con organizers. I run IronGeek.com. We hope everybody's enjoying the conference. There's a few announcements that Dave wanted me to make. Anybody who wins the CTF, there's a contest where you can basically get a lifetime free badge to DerbyCon. So I want everybody to know that. Also, I have a book here to give away. It's Android Forensics by Andrew Hogue. I think I'm pronouncing his name right. And I need to come up with a question for that to tell everybody. So, well, considering it's Android Forensics, can anybody tell me what what type of virtual machine Android apps run in? Okay, I had no idea who said it first. You said it first? You can have it. Come on up. You have that. And let's give a warm DerbyCon welcome to Dennis. He's going to come up here and give everybody a talk.
All right, good morning. My name is Dennis Kuntz, and you can make fun of my last name. I need it to be creative, because I've heard most of them. IPKS is the one thing that I put up there. I'm very proud of that. It's within the spirit of the Scanless PCI certification, as well as the Application Security Specialist certification. Check out ipks.org. All right, one thing about the talk, you're going to see a bunch of walls of text. Not going to read it all. Don't expect you to read it all. When I get presentations online that get posted, a lot of times there's context missing. And so what I try to do is I put in a lot of context so people that can't be at the talk, they can actually figure out what I'm talking about. So the me drink protocol from Deviant, I'm implementing that today into to follow into what I'm supposed to do is I'm supposed to take some sort of beverage and fill a container. And now, anytime I screw up or there is some need from the audience for me to take a drink, I have to take a drink. And I know all of you were up late studying and furthering your information security skills. And so I thank you for being here this morning. But also, anybody who asks decent questions or anything like that, you guys get to come up and get a free drink. So, protocol is in effect. Huh? No, but I have 2 bottles, so. So I'm prepared. All right, kind of introduction. There's a lot of tools people are familiar with in terms of searching for text, and that's something everybody's familiar with, both from an adversarial perspective as well as a blue team perspective. Things like FOCA for meta information, bin text, strings, Cornell Spider, blah, 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 blah. DLP does text almost primarily, which is why one of the ways to subvert that would be encrypted protocols. And they can work, again, on red or blue team kind of scenarios. OpenDLP was created within the context of penetration testing, but can be used for the defense side as well. Now, one of the things, the premise of this talk is, what about those situations where you have some sort of data that's not text-based, it's within images. You're not seeing that with any of these tools, and you're not going to find it. So that's kind of the whole premise of this talk. Some OCR history real quick. It was interesting to me that it was actually the first patent was filed in 1929. And essentially what OCR is pattern recognition. That's pretty much what it is in a nutshell. And it's to be differentiated with intelligent character recognition, which be like gestures, handwriting, and stuff like that. So this is primarily based, OCR is for fonts and printing as opposed to handwriting. Modern scanners now, when you do an OCR, if you have the ideal conditions, you can still have 99% or 99.9% accuracy, or 99.99%. That can still translate when you have large documents with a huge number of characters. That can translate to a whole bunch of errors still. So that's pretty impressive. The biggest problems right now have to do with faxes, scans of documents, because those necessarily have degraded text, especially faxes. They're not made for the fidelity, they're only made for readability. And so what happens with faxes is you'll actually have the same character show up as a different set of pixels because you'll have kind of random pixels on and off around the character, adding to the fuzziness. So that's a big struggle for the OCR software. Some background, where the approach that I'm going to talk about, where it came from, was I was working, I forget what I was doing, it was a tutorial, and I had some shell code that I needed to use, but it was an image of the shell code in the PDF, so I couldn't just copy the text, and I'm lazy, and I wasn't going to do it, and so this is what the actual shell code looked like, so I had to figure out what to do, and I'm distracted easily, and I'm lazy, so what I did was I looked up command line OCR, and I found something called Tesseract OCR. And what I did was I simply just downloaded it, took the image, I made a few modifications to the image, kind of boosted some stuff, changed it to grayscale, some other stuff, and I ran it through Tesseract, and this is what I got, which was a lot better than typing it in. So I went through and I just corrected what was wrong, and that was it. It wasn't close to what the original, but it was close enough for me not to have to type most of it. Now, fast forward a few years, and that's when I went on my way, and I left that cheesy thing in. I meant to take it out. I'm doing a penetration test, internal, and it was scoped for PCI. I was only allowed to look for credit cards. And I came across a multifunction printer that was left with admin credentials, default admin credentials. And so what I did was I went in, I did other things, but I set it up to forward to me all PDF, all scans and faxes as a PDF to an email address. And I just left it for a couple of days while I did other things. What happened when I came back was I had 608 documents that had been emailed to me as PDFs. And when I kind of started sorting through them and looking at the data that was there was Social Security numbers, arrest records, all kinds of HR documents, credit cards, full pans, everything you can think of. It was across the board. It was a booty. It was awesome. So for the win, right? All that data. Well, again, it's images. So here's what the problem was. Don't read that secret message, please. These images are basically the same. Visually, they're pretty much exactly the same. Okay? But then when you look on the binary level, these 47 bytes that I've highlighted are the only difference between those two images on the byte level. And when you look at those 47 bytes, there is a nested message in there. And that's the message right there. And so that message is hidden within the binary level of that image. And if you're using DLP or other tools, or heaven forbid you have the time to go through and look at stuff manually and figure it out, God bless you if you do, you might be able to find that binary level stuff. But none of those tools will find what's hiding in plain sight, which is the message I told you not to look at, okay? None of them will find this message that is blatantly in the image. So that was the problem with all the PDFs that I had, right? Because all that sensitive data was as an image in the text or in the PDF. So, so now I'm struggling. So then I thought back to when I had done that stuff with Tesseract on that shellcode image, and I thought, I wonder if this would work. So what I did was when I first looked at Tesseract for this particular thing to see if it would work, I was not getting the results even as good as I got when I first used it on the shellcode. And so what I did was I kind of looked through some different OCR tools and kind of played around with them just to see what I could find and stuff. So what I'm going to kind of do now is kind of go through some of those tools that I came across for my approach that I was trying, just to see what would work, what wouldn't. Tesseract, again, balls of text, not going to read them. Tesseract is actually considered one of the better open source OCR applications out there. And it's actually, even though it didn't work within the context of the results of the penetration test, it did work really, really well on the testing that I did later on that I'll get to in the second part of my talk. So when I tried it, it didn't work, and that was the inspiration to kind of look at other tools. It actually is a very good piece of software, though. It's been around forever. It's been around since 1985 and has been developed on and off since then. OCRAD, which is the GNU OCR software, the failings with this were, especially at the time, my lack of understanding of how to deal with these, because there's a certain thing you have to do with, again, pattern recognition, right? The more patterns you have to recognize, the more successful you're going to be. So there's a concept of what's called training, and I'll get to that later. But there's a concept of what's called training with OCR software, where you give it repeated versions of something so that it can learn what that is and how to translate it, okay? And so what happens is when you see something like this, all these underscores, what that tends to be is the OCR saying, I don't understand what's here, so I have a default character that I'm going to put when I don't understand a character. And so this, to me, is simply a training issue. I didn't know how to train the OCRAD, so I didn't. And since I was looking for something quick and dirty in this particular scenario, I didn't want to go through a whole rigmarole to try to figure out how to use it correctly. So it probably has a lot more potential, and the failing I'm going to assume is mine. This one I actually came across later, OCROPUS, and this was, I believe, it's in Google code, but I believe they actually took on sponsoring the development of it. And this one is really interesting because it's more of a framework that you can tack on different OCR and different kinds of applications and different kinds of extensions to it. And it actually has a commented out ICR module as well. And so that to me is really interesting because I want to investigate that further, because it would be kind of cool, because some of these forms that you come across in these faxes are actually forms that were printed and people wrote stuff in, so they might have written their credit card number in. So if I can leverage OCR or Opus to maybe look at some of the handwriting, get some of that, that'd be cool to have that all built into one place. So, it's really interesting software. And again, I ran the shellcode through that, and again, you see the repeated characters here. The default character is going to be the £. So that's what happened here, and it's another training issue, or lack of training issue, just like the OCRAD. Now this one, in terms, GOCR, in terms of my original thing, or the penetration test, all those PDFs, GOCR was the beautiful meeting of all minds for me, because it was easy to use, training was really, really simple, and it got good results. So this is what I went with for my the penetration test with those 600 documents. And so that, I actually ran the shellcode through that, and that's actually pretty good. I didn't know about GOCR when I had the shellcode, only Tesseract. So GOCR is probably what I would have used, but because the actual results were really, really good from it on that shellcode. This was just kind of my equal comparison across all of the OCR applications to see how they responded out of the box, no other mods to the image. So now, with GOCR and training in general, there are kind of two concepts of training an OCR application. There is you telling it how to interpret a set of pixels, because again, at the end of the day, all we're dealing with is pixels, and they are recognizing a pattern of pixels and equating it to some sort of character, right? That's all OCR is, essentially. And so there's two kind of concepts in the sense that you can say these pixels equal this character. And GOCR makes this very, very simple. Literally, if you go in and you have this image and you cut those pixels, you put it into that image, and you save it, then all you need to do is, with GOCR, if you just do, let's see, actually I copied it somewhere, or just do echo, let's see, 5.pnm, and then 5. So what I'm doing here is I'm saying the image 5.pnm is the character 5, and that's all I'm doing. Now there's a file called db.lst within a data directory for GOCR. I do that, and now when I run it and I tell it to use that directory, it knows that when it sees that series of pixels, that equates the number 5. So that's me telling it what a set of pixels means. And so that's one part of OCR training. And it's really, really simple. So now the other one is when you tell GOCR to tell me what pixels it doesn't recognize. And then you can tell it. So it's really, really kind of cool within, and I'm going to do a little demo for it. But right there, see, it's pulling out those where it says city, and obviously to us it says city, but it's saying I don't know what this is. So I just simply type in what it is, and then it makes an entry into that db.list. So now, let's see. So now here what I have is I have an image. It's hard to see the font, but it's an image called Kinko's-1. And what I did was I sent myself to get some examples. Let's see, I'm going to copy this real quick. I sent myself some faxes. This one on the right was done through an online fax service for free, so the fidelity is really good. What I did was I just made a whole bunch of different PII type of things, credit card number, social security number, phone number, that sort of thing. And I sent it to myself there, and I didn't want that really good fidelity because that wasn't going to give me a good idea of what actual faxes look like because we know how shitty they normally look. And so what I did was I went to Kinko's and I faxed it to myself. And that's what it looked like on the left when I faxed it to myself. And you can see it's really tweaked. And that gets a lot more difficult for the OCR applications. So I kind of have a side-by-side thing there. And so what happens here is I'm going to tell GOCR to go through that first page, the one on the left, the Kinko's fax. And I'm going to ask it to tell me what it doesn't recognize. Let's see. PPM. What I got wrong here? Guess I have to take a drink, huh? Woo! It's by design. I have to fill it back up. I don't like to drink alone. I also have Bullet, so you have your choice. All right. So let's see what I did wrong here. B data, Kinko's 1 ppm. Drink. You may get your strippers that you wanted very soon. All right. So I have no idea what it's doing wrong here. I even see that's why I copied the command into a text file because I made sure it worked yesterday. So anyway, I'm not going to waste time with it. You get the idea. It'll go through, and then what I did was I actually copied one of the images when I did run it through. And see, what it did was it pulled this set of pixels out, and it said, I don't know what this is. And I said, that's the number 0. Okay? And then it saved it as this image. So now when it goes back through that document, it's going to automatically recognize that set of pixels as the number 0. Okay? So those are the two parts. You tell it what things mean, and you have it tell you what it doesn't understand, and you translate it for it. So what does this all get you? In this particular case, I was only scoped to look for credit card data. I wasn't supposed to see the social security numbers, their arrest records, and all the other stuff. I wasn't, of course, I told them about it, but so what I did was, in terms of harvesting my data, I focused on credit card data. Okay, so what I did was I really tuned it towards my approach towards finding credit card data. Luckily, what I did was, of these 608 documents that I had found, they were very disparate. I mean, in terms of form, format, content, everything. And I was not going to go through 608 documents, right? So what I did, though, I was lucky enough to find one document that was a chargeback form that had the full PAN and everything. And I was able to find a few examples of that document. So what I did was I went through and took about a half dozen of these, and I pulled all the individual digits out, created entries in that db.list file for GOCR. Then I went back through and had it train itself. So these are the entries that it would put in on the bottom right. When it goes and gives me those patterns it doesn't recognize and I tell it how to translate it, it's going to make those entries at the bottom. The ones at the top are mine. So now I have this db.list file with a whole bunch of translations for these types of documents of how to interpret the individual characters specific to credit card numbers. And what was cool was when I was telling it, remember, I'm only looking for digits at this point because I'm only looking for credit card numbers. And when I got through with all of the training, fully 90% or more of what GOCR was telling me it didn't understand was alpha stuff. And I didn't care about that. It didn't need to interpret alpha stuff for me because I was only looking for characters. So I was getting a fairly thorough training of GOCR on these 6 documents in terms of it understanding what was in them from a numeric standpoint, which was good. So then what I did was I kind of did some tweaking. There's some defaults within GOCR. Like what it does is it expects a 95% confidence rate in terms of its ability to interpret a character. And you can set that confidence rate. So if you look at the second to the last parameter there, the -80, I kind of played around with it, and 80% confidence actually gave me the best results. It gave me a good, solid covering of the data that I wanted it to interpret. I told it to only match numerals, and I told it to go ahead and use only my library of how to interpret the dictionary that I had created. And then on Root Ninja's site, again, I'm no Uber code or anything like that. And so I went and I found on Root Ninja's site a way for me to kind of parallelize this and use, because it's slow. By the way, these things are slow. They are not meant for high throughput, okay? So the actual processing is intensive, and they're not optimized for a high number of documents. So I was trying to get as much speed out of them as possible. And so I found this little snippet to parallelize the processing of the documents. And I just set it loose on all of those documents, the 608 documents. And so what does this get me? This gets me 43 full pans confirmed. I went back to the documents that they were in, and I found and confirmed that they were valid credit cards from these documents. So I didn't have to go through the 608 documents. I got to go on my way. And me finding those, you might not even be able to get a scanless PCI certification. So that was cool. However, we still have a problem, right? Because I was lucky in that scenario to have multiple versions of a document so that I could go and pull, so the more, again, like I said, the more representations of a particular set of pixels that you want interpreted as the number 5, the number 0, whatever, the better chances you're going to have that when it comes across that in a similar document, it's going to be able to recognize it, okay? What if you don't have that opportunity? What if you have one version of a document and you have a whole bunch of documents and every single one's different? So within the scenario of what I did for that penetration test in terms of having these documents emailed to me, I had no idea what I was going to get, and every single one of them could have been different. So I started thinking about that. And so I tried to come up with a way to approach that problem. And so now we get to go to the gun show now. The shotgun approach. I'm going to just throw every bit of shit I can at it to maximize my percentage of the ability for certain characters to be recognized. And so we're going to cut to the chase and kind of outline the approach. What I did was I needed some sample documents. Now this talk is not about harvesting faxes from the internet. However, that was a neat exercise in this. I came up with some Google dorks. Came across almost 100 faxes, everything from grand jury, local government documents, including bids, lots of legal documents. There's a lot of stuff in terms of newspapers and news stations that receive faxes that they use for press releases and stuff. There was one, Dennis Kucinich, suing NBC, and there was a court document of the actual lawsuit being filed. There's IRS documents, political campaign documents, copyright, everything. But every single one of them was different. So this was a good thing. But I just thought that was really interesting, the stuff that people had out there. Not surprising, unfortunately, but it was interesting. Anybody needs some of the Google dorks, I can give them to you. So the shotgun approach, what do we know that we need to solve versus having a whole bunch of documents that we can train with, right? We know that each OCR program operates differently out of the box, is what you saw earlier in the talk, right? Out of the box with no parameters, no training. They each have a different success rate depending on the document they're being given. And training an OCR app actually ranges from completely difficult. One of the things I didn't read in that Tesseract document, they actually even say that training Tesseract is only for the brave of heart. It's not trivial. It is a non-trivial thing to train Tesseract. I want to get more into it to figure out how to do that, because I think it'd be cool to maybe automatically extract sets of pixels and have some automatic training going on, but that's out of my ability at the moment, so I got to figure out how to do that. So we know that. So if the more OCR applications we have, the more likely we're able to, one of them will have some success with a particular document. Different image enhancements may help. And one of the things that you're going to see, and I'll mention it later, was I found a really good training example on Blue Hat SEO. It was a user-submitted story on how to break CAPTCHA using GOCR. And what he did was he wrote a little application, just a little C++ application, that what it did was it took, because the CAPTCHA that they were using was a bit fuzzy, okay? So the fidelity was bad on purpose, obviously. And so what it did was it looked for 2 pixels that were on, 2 black pixels, and said, are these within a certain proximity of each other? Like, are they 1 pixel away? If they are, then I'm going to assume that they're supposed to be together and part of the same letter, so I'm going to turn that pixel on between them. And so it actually increases the fidelity of the image. It's very simple, and I thought it was awesome. So I brought that into this, and right now, when you see the tool, I actually am going to release a tool for this. You had to answer that question when you submitted a talk, and I wasn't going to, but this kind of came out of me playing with it. In the tool, that's the only image enhancement I do right now. I want to add more image enhancements later on, depending on what I figure out works and stuff. So different image enhancements can help the success of the OCRs. Running OCR software is only useful in this stuff on large numbers of documents. There's a lot of overhead. It takes a long time. If you have 3 PDFs, just open them and look at them. So it's not really that great. But when you have large numbers of documents, it really is helpful to have this approach be thrown at it. And once you have the results, you still have to sift through, because you're going to have a fair number of false positives, because again, you're casting a really wide net. That's why it's a shotgun approach. You're just throwing shit at the wall, see what sticks, and then you're kind of sifting through results. And what I've tried to do is to minimize the results you have to go through, but there's still a lot. So now what we need to do is we have to allow for the usage of multiple OCR applications, right, with this shotgun approach. Training, generally, at this point especially, is not available. So we need to make up for it by having as many OCR applications as possible take a stab at the documents we're looking at. And that way, again, we're maximizing our success because of their different abilities to perform out of the box. We need to be able to allow or implement image enhancements, as I said, and so being able to do that over time. Automate as much of this as possible to minimize you having to go through all the shit that comes out of this. And you need to get some way to get a baseline of useful data without having to look for it manually. I do this as well. Allowing for but you still need to be able to do manual searches after the fact. So you're going to try to say, hey, go see what you can find, okay? Go see what you can find, but I have some stuff, either I forgot to put it in, I have some regexes that you can use that it will automatically look for out of the results that it gets, but maybe I forgot one, or maybe there's other stuff I want to look at that's not in the set of regexes that it did automatically. So I still need to have the original text files that were generated to be able to go and sift through them for whatever I can come up with in terms of what I define as sensitive data within this. So what I came up with right now, it's just a bash shell OCR shotgun. And what it does was it creates 4 images. It creates PPM images, which is used in 3 of the 4 OCRs that I use. And then that enhanced one where it turns on that pixel between them that I talked about. And then TIFFs for Tesseract. Because a lot of them, they're really strange in terms of the kind of documents that they use and require to be used for running them. And it automatically runs the 4 different OCR applications, and it automatically does a set of regexes against the results, and then what it does is it puts them all into directories for you to either get rid of, to go through, whatever. So it separates the PPMs from the TIFFs from the text files. The text files are all of the files that it came with from running the OCRs, and then there's a grep file where it grepped those regexes and gave you the results. And it gets rid of all it separates the wheat from the chaff, because a lot of those are end up in 0-byte files, so it cleans that up as well. So you're just left. And then what I did was I implemented a naming convention where you can look through, without having to look through the actual text files, you can actually just do an ls on the directory, and you can see, by the name of it, you can see what regex was the result of that text file. So what regex was successful? What OCR application successfully got that regex? and whether it was one of the regular images or an enhanced image. So let's see if this demo works. All right. And real quick, I know you can't see this. I'm going to highlight it so you can see it. This is where you have the regexes. So I've separated them out into numerical regexes and then alpha regexes. And so this is just stuff I just thought to put in to look for. And so again, you can just go ahead and modify it, get rid of some, add whatever if you want to look for company names or whatever it happens to be. So right here what we have is we have two faxes. We have that Kinko's fax and then that fax through the internet with the high fidelity that I showed earlier, just for those who may have come in late. These are the faxes that are going to be done with this. So we've got the one on the right that I sent myself through internet fax, so the fidelity is really good, and then one that I sent from a Kinko's fax machine and is pretty shitty. And then that clean pick at the top, that's that C++ program that the guy wrote off of Blue Hat SEO for enhancing the image. So this takes about, again, not fast, it takes about 2 minutes. And so what it's doing is it's going and creating all the images. It's taking a PDF, and for every page of the PDF, each of those faxes has 2 pages, and it's going through and it's creating an image for each page individually. So each page has its own image. And then what it's doing from there is it's creating the PPM files and the TIFF files, and then it's going to go ahead and run Tesseract, and you'll see a lot of feedback from Tesseract and OCRopus down here. I don't know what a lot of this stuff means within OCRopus, and that's the boxes searched and found and stuff. And there's a whole bunch of very technical ways to train this stuff that I still have to dig into. So this is, I think this is applicable for anyone who is not very versed with OCR, because I'm not, and that's one of the things I'm not as an OCR guy. And so one of the things, this is very applicable if you don't know a lot about it. I'm going to try to get more into understanding what to do with these things and the proper way to do with them so I can maybe enhance the tool. Anybody that knows about this stuff is more than welcome to make modifications. I'd love to know about it. So this won't be too much longer, and I'll show you what the results are. So the Tesseract 2 entries at the top are for the first 2 pages from the first fax, and now we have Tesseract operating on the second PDF, or it's the second fax at the bottom. And so then OCRopus is going to do those, and then it'll be done, and it will run the regexes on the images that were found. So talk amongst yourselves.
Are you grabbing any metadata from the files themselves?
I am not. With this, and that was something somebody had mentioned to me, and so that is definitely something I could do, but the focus of this was about the image data as opposed to metadata, because metadata is going to be text, blah, 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 and there's tools for metadata. So this is focusing on the image data. But it would be nice to have that ability within the same tool to look for all of it, so that's something I've thought about.
Depending on the fax machine, it'll actually contain the fax.
Right, okay.
Is it pegging your CPU, like when Tesseract's running?
Yeah. Yeah, it's fairly CPU intensive on this stuff. So, and that's why, so by the way, oh, you can't read it. I did a little, this was for Evan Booth, to go see Evan's talk. Power, 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 power. So go see his talk. That won't be in the script when I put on my website. So now what we have is, we have again the greps directory, the ppm, tiff, text, whatever. So now we go into the grep directory, what the hell's that? Oh shit, I'm not following the protocol. I'm supposed to keep it filled. This poor cup is going, these are big shots. What?
Is there a way you can blow up the font in that terminal?
Yeah. All right. A bunch of geriatrics out there. All right, so now here, if you look at some of these things, again, there's that naming convention, and you've got like Social Security 1, Kinko's, page 1, the cleaned image or enhanced image, GOCR, blah, 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 all that stuff. And so what you can do is you can just do something like, I want to get all SSN 1s, and so this is going to show what it found. And you'll see that some of them actually near the bottom, see like like 4 or 5 lines from the bottom, 543210. That's actually a credit card number, but it just, the pattern I have in there is pretty lame, so it just matched the patterns all. But you'll see that it did pick out the social security numbers, and some of the things I did in the shell script is the OCR applications are funky sometimes, and what they'll do is, because of the way, especially on the messed up facts, the one that doesn't have the really good fidelity. Oh, I never drank. I'm gonna be wrecked for the other talks. Damn it. Yeah, I'm gonna have to have a meta shot up here. All right. Dude, nobody's drinking with me. Some of you guys have asked good questions. You need to come up and get a shot. Rick, you need to get a shot, dude. No, you're right. It's Herod the dog. I'm here to help. I'm with the government. I'm here to help. So you can see, anyway, what I'm saying is that what it does a lot of times is when, especially with small, like narrow numbers or narrow characters like L's, ones, that sort of thing, what it will do is, because of that lack of fidelity in the faxes, it will interpret the space between them as an actual space. So a lot of times it will put a space. So if you have a regex for, say, a social security number that's looking for three numbers in a row, well, sometimes it'll put a space. So what I did is I have 2 kind of versions of regexes that I run, and I think, let's see here. If I scroll up here, you'll see at the top there where it says no spaces. So what I do is I run it through and I get rid of the spaces and I say run the regexes. So this is where you're going to get a lot of shit, right? A lot of stuff you have to sift through. And because of the naming convention, you can do stuff like that to be able to look at big swaths at them all at the same time without having to open up each one in a text file, right? So there are easier ways. You can obviously look at it by the different OCR application. You can look at it by the regex that was run. You can look at it by only the enhanced images or whatever, any combination thereof. So that's essentially what it gives you in terms of being able to go through this stuff. And there's a lot of false positives, but it is really good at getting the stuff that you want it to get.
So are you going to be sharing your own database too? So whatever your application has already done from your own experimentation, do we get that too? Or?
Well, that's not necessarily applicable, because the whole point of this is each one of these faxes is considered an individual thing, and it will probably not be relevant in terms of it being trained on that and running that against some other fax, because the lack of fidelity is generally pretty random. So the same fax may have an issue if it was sent again, it almost might be looked at as a different fax. Well, you're right, and one of the things that I thought about doing, this is going to take a lot of time, but what I thought about doing is taking some common fonts, taking some stuff like that, faxing them to myself, and then making image libraries of that, and that's something I thought about doing, because then I would publish that as well. But that's going to be fairly labor intensive, and I just haven't done it, but that's something I thought about doing. So, but I have to figure out, like what fonts and so on and so forth, and obviously the end result, every single font. But then you have to worry about the other thing you have to take into consideration is, and what I did on those faxes, what I put different. You shut up. He only wants me to drink because he's rooming with me. But what I did, because the other thing, these are all the same font, right? But now you have to think about font sizes, bold, italic, and so now you're exponentially increasing the number of things that you're telling me that you want me to do. But it's something I thought about doing, is taking some common stuff and putting it out there.
So it's kind of easier for the guys to kind of defeat the whole purpose, because you could have a setting on these new faxes where it just moves everything by 1 pixel or 2 pixels. So the whole thing changes on every fax it's sending.
Right, but that's one of the reasons that you're using the shotgun approach, right?
Oh, yeah.
Is to make up for that lack of ability to know what's there and the lack of training. That's the whole reason. And so within the script itself, you can actually add fairly easily other OCR programs. Because there's if you go to Wikipedia, there's actually a list of OCR, I don't know what time we're, okay. There's actually a list of OCR software, and there's a shit ton of open source software. So you can add more. These are just the 4 that I did, and so you can increase that as well. And then another approach is the image enhancements, right? In terms of, okay, we're gonna, and you need to make sure to do it on the original one and the enhanced one so that you're getting all the opportunities to get it right. All right. No, I'm actually starting to feel it, so. So, yeah. So the pros, again, it takes care of automatically throwing a lot of ammo. It's easily extendable in terms of adding regexes, different OCR programs. It covers a lot of the ground that would be impractical otherwise in terms of if you have, in my case, the 600 documents that I had, not practical to go through every one, just not. Allows the possibility of data retrieval that you may have otherwise missed. So the cons are slow. It's really slow. Again, those 4 pages took 2 minutes, and that I've never run it across the 600 faxes because I don't have those anymore, or the 600 faxes. That was 2,000 pages. That would have been a nightmare. It would have to run for a couple days probably. And the very nature of it, you're going to get lots of false positives. So if you're willing to accept some of this stuff to get data that you might not otherwise have gotten, then it overcomes that part. And right now, you're going to miss relevant data. You're not going to catch everything because you're casting this wide net. There's the fidelity and the lack of training and blah, 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 blah. You're just not going to get everything you need. But you will get stuff you would have missed otherwise, right? And so I'm sure there are other things. Some final thoughts is regarding the OCR shotgun itself, additional image enhancers that like I said, creating faxes of common fonts, which we just talked about, dig into the options for other OCR apps and additional OCR apps. So additional options for the ones that are there in terms of, a lot of them actually have built-in image enhancements. So you may be able to implement image enhancements for one type of OCR without having to go and actually code making those image enhancements, because coding image enhancements using ImageMagick or whatever, at least for me, is going to be a lot harder than just setting some switches. Yeah, we're real close. So that's kind of things I'm thinking about with OCR Shotgun. Any other thoughts, any other ideas that you can offer? And I'll give contact information at the end of this. Please let me know. I'd love to know about it. If you can do it, even better. And then additional research regarding the topic. And I've only looked at a small number of the open source OCR apps, and I need to look at some of the others. Tesseract, again, is kind of the king, if you will, in terms of this scope, as narrow as the scope is. Look into commercial software options. There's actually a very interesting company that kind of pissed me off, Abby, A-B-B-Y-Y. They're out of Russia, but they have offices kind of all over the place, San Francisco and some other places. And they actually have something that I believe would be really, really good from everything that I've read about it. There was something back in 2010, there was a press release, and this isn't my original talk. Anybody that's seen my original talk? Back in 2010, there was a company, another company in Russia that had a DLP product that Abby has this thing called FineReader, which is a commercial OCR, but they have an API. They have FineReader API, okay? And this Russian company, it was like Infodata or something like that is the name of the company, I can't remember, had built into, there's a press release about them having built into this DLP software, this Abby FineReader API, this ability to do DLP with OCR. It's gone. It no longer exists. The only thing I can find is the press release. If you go to Infodata, I think it's Infodata. If you go to their website, the product doesn't exist. The product they have for DLP mentions nothing about OCR. And the only that press release is like on Abby's site, but that's it. There was another press release from Abby about some proprietary thing they set up with Hyundai to build in OCR into a DLP solution. Now this is a proprietary thing. It was an enterprise-wide solution. So, because one of the things with DLP and OCR, which is one of the obvious applications from a defense standpoint, because I've been talking about it mostly from an adversarial standpoint. But from a defense standpoint, there's a lot of applications for this stuff if you can get it to work properly. And one of the biggest hindrances is the processing time, the processing intensity to munge through these things. And so what I could gather from the press release that they did with Hyundai, it was some sort of batch processing that they did, where they would bring, I don't know if it was off the line, if they mined images or how they did it exactly, but whatever it was, the images they brought over to a centralized server that then processed it with the Abby Fine Reader. I contacted Abby about getting kind of a research copy of the API, and they said, no, give us $6,000. And I said, fuck off. So what I'm going to do is I've done some OSINT on them a little bit, so I'm going to go and contact some of the tech guys and see if I can work with them to just get a research copy to play with it, see if it has a little bit more oomph than these open source things. But right now, everything I've done is open source just because I wasn't going to spend $6,000 just for DerbyCon. So, and then as far as the application of the technique, some thoughts are, while I have focused on, again, faxes and scan, it applies to all images. You can use this for everything. And obviously, you're going to get better results with things like screenshots, things where the fidelity of the images are awesome. You're going to get much better results. So again, DLP is a great, that's the thing that screams to me for this is DLP from a defense side. So you can mine that stuff for all kinds of data. DLP is a great place, but Matthew Sayer actually a week, and I think it was Matt Jazork who forwarded to me. Was it you who sent it to me? I can't remember what university. Richland College's digital forensics program. He's a student there, and he actually released a tool, and it does nothing fancy with OCR. It runs Tesseract blind. Tesseract, no enhancements to the images, no command line arguments, nothing, just Tesseract in the image to get the out-of-the-box results. But what he did was he applied it to forensics. There's what he would do was he had images extracted from an NCase file. And the big thing from a forensic standpoint for his tool is that it maintains the folder structure of the images. And then he runs Tesseract on it to try to extract data. So I actually was able to have some email conversations with him before this, and he and I are going to hook up on Skype. And I'm going to kind of give him the results of my work and see if they can apply that and use some of the techniques and maybe even take them further within the context of their program. So forensics was a really cool idea. There was somebody I was talking to yesterday or something that had an issue a week ago where some of this stuff may have helped them with some forensic stuff they were trying to do. And I think that's it. Q&A. I'm going to leave it running.
What was the minimum DPI that you were using for your testing?
I don't know. I did whatever came through because I didn't even worry about that because I was looking for real world, and so I don't know, to be honest with you. Whatever the fax machines were.
So, like you, I'd be interested in numbers, just numbers, certain combinations thereof, and you're doing that with red X's. Is there anything to the OCR programs to say don't try to match A through Z, just match numbers?
With GOCR, there's actually a command line switch that it's the -C where you can tell it to only do alpha, and I believe you can actually put in regexes in there. There's some level of that with GOCR. The other ones I don't know, but GOCR you can.
Okay, cool.
Anyone?
I was thinking it would be, you could really easy distribute this. I mean, you extract the images on one machine, rsync it down, and then just have your loops go to multiple 8-core machines.
Yeah, absolutely, absolutely.
CPU processing power is
Yes.
not even an issue.
Yes, absolutely.
I mean, because the jobs take so long to run, and while that's going on, you can be rsynching up to the next job.
Yep.
And then,
Yeah, absolutely.
you're doing 2 cores because you're on your laptop.
Right. Oh yeah, if you got the absolutely, and again from the DLP perspective, you're probably not going to get real time DLP, but in terms of being able to process this within a reasonable time, then that's what you would do. So, anything else? Drink. All right, I'll drink. Dude, I've hit this pretty good. Oh wait, it's already full. Sweet. Drink. All right, screw the other talks. All right, I'm done. Thank you.